So in the next two, we're going to talk about how to use the calculator to help us find increasing and decreasing places. So I'm going to go to my calculator and I'm going to type in that equation for 53. Notice I'm only looking at this from -2 to 2, so I'm going to adjust my window on this as well. So we're going to go to, here's our calculator, y equals, and we're going to type our equation in, x to the third minus 3x plus 2. And if I hit graph, there's my standard 10 by 10 window. And by 10 by 10, I mean that I'm going from -10 to +10 here, and then -10 to +10 here along the y and along the x. Now, I only want the piece from -2 to 2, so I'm going to change my window. I'm going to change my x max and x min to reflect that restriction. So you can see how it changes the look of that graph. Now we're looking for increasing, decreasing. So we can see that we're increasing from here to here, and then we're decreasing, and then we're increasing. But to find those intervals, we really need to talk about where is this maximum happening and where is that minimum happening, because that will help us split this into increasing and decreasing pieces. So to do that on the calculator, we're going to hit second and trace. And I'm going to find that maximum first. Hit enter. So it's going to ask you some questions. The first one is left bound. If I'm trying to find this point, I need that blinker to the left. So I'm just going to hit the arrow, arrow, arrow over to the left until I get to the left of where I'm trying to find. Now when you hit enter, notice that this arrow popped up here. Now it's asking you a new question, right bound. So I need to move that blinker to the right. So there I am to the right, hit enter, and now I'm good there. So now it's asking us for a guess. So we want that blinker just close to that point. Now notice the arrows are facing each other and that blinker is in the middle of the two arrows. So when I hit enter, it will give me that value. It's telling me the maximum is at -1 and the y is at 4. So I'm going to go back to my notes over here. And the maximum is at -1, 4. Now we also need to find this minimum. So it works pretty much the same way. Second trace takes us to the calculate menu. Now we want minimum. We want the blinker to the left of the point you're trying to find. So keep in mind we're trying to find this point. So I need the blinker somewhere on the left. Hit enter. It pops an arrow up. Move that blinker to the right. Hit enter, pops an arrow up, and now I need the blinker in between the two arrows. The arrows have to point towards each other. If they don't, then you will get an error message. Blinker's in the middle, hit enter. Now it's giving us the minimum. Now notice they're using scientific notation here, and they're using some kind of funky stuff here. There's going to be a little bit of error in the way the calculator computes this. It's using an algorithm to help find that minimum and maximum. So what we want to do is round this because there's a little rounding error in that algorithm. So this is really the number 1, 2.2 e to the -12. Remember that -12 means you move that decimal 12 places to the left. So we would have 11 zeros in front of that 2, which means that it's virtually 0. So our minimum is at 1, 0. So I'm going to write that over here. So our graph, and I'm going to recreate this here. I'm going to zoom in. So -1, 4 was a maximum. 1, 0 was a minimum. We were looking from -2 to +2. So this graph kind of did something like this. So let's find minimums and maximums. We found the minimum and maximum on the calculator. So we've done part of the problem. Now we need to talk increasing, decreasing. So if we look at increasing, this guy's increasing from -2 up to this value of -1. It's decreasing on that next piece in between that maximum and that minimum. So it's decreasing from -1 to 1. And then from 1 to 2, we are increasing. So there's our decreasing, increasing intervals. And we did that using the calculator. We could do the same kind of thing on the next one. It's going to work the same way. If we were to graph this, x to the 5th minus x cubed. And we're still looking at this from -2 to 2, so my x window is okay. But look at this. We can't really tell what's going on there. Those y's are just too big, so let's change the window. Let's kind of zoom in on what's going on. Maybe let's try -1 to 1 and see if that gives us a better picture of what's going on. So before, we couldn't really see what was going on because our y's were going from -10 to 10. But you see how when we zoomed in on that, and if we were using Desmos, we would actually be able to pinch in and out. It really changed that appearance of the graph. So now let's find those peaks and those valleys. Let's find that maximum and the minimum. Second trace, we're going to do the maximum first. You want the blinker to the left, enter, to the right, enter, and then in between. So we're at -0.77 and 0.19. Now we're going to find that minimum. Left bound first, then right bound, and then guess. So we have 0.77 and -0.19. Now, I do want you to notice that this one has some symmetry going on. This is an odd function because this is symmetric about the origin. So if we look at increasing and decreasing here, we are increasing from -2 up to this value, and that x value was -0.77. And then if we look at that graph, in between that -0.77 and this 0.77, we are decreasing. But then we were increasing to the right of that 0.77. So from this 0.77 on, we are increasing. So there's our increasing, decreasing intervals for number 55. The last thing in this section has to do with average rate of change. Anytime we talk about average rate of change, we're really talking about slope. So always think about slope here. And what we're really doing is find the slope of some secant line. So let's look at an example. 67 is asking you to find the average rate of change from -2 to 1, and then the equation of that secant line. And we're looking at g of x equals x squared minus 2. So if we're looking at average rate of change, I'm going to abbreviate that AR, average rate of change. ARC. They're telling us we want to find it from -2 to 1. Those are going to be x values always. Well, to find slope, you got to find the y value also. So let's find that y value by plugging -2 into that function. If we plug -2 in, we're going to get 2 out. So then our point is -2, 2. That's a point that's on that graph. Now we got to find the y coordinate for that 1. So let's plug 1 into that function. So 1 minus 2 is -1. So our point is going to be +1 for the x, -1 for the y. So to find the average rate of change, we're really finding the slope. And it's going to be y2 minus y1 over x2 minus x1. So we're going to get 3 over -3, which is a -1. So now we have the slope. We have points. Part B is asking us to find the equation of the secant line. We can use point slope formula to do that. So we're really seeing things from that last chapter starting to tie in. Some of those things from way back in the day. So we have y minus, it does not matter which point you use, I'm going to use that first one. So y minus 2 equals -1 times x minus -2. Be careful and watch your negatives on these. Y minus 2 equals -1 times x plus 2. I like to clean it up first before I distribute. So we're going to get that secant line as y equals -x. So here's what this means. Let's graph everything so we can see what's going on. So I'm going to go back to my calculator. I'm going to have x squared minus 2. And I'm going to use a standard window. An easy way to do that is go to zoom and zoom 6 for standard. So there's my quadratic, x squared minus 2. We found the graph -x, y equals -x. So let's graph that on top of the quadratic. There it is. So this is called the secant line. What it's doing is it's going through the graph at a couple of places, and I'm going to zoom this in just a little bit by changing my window. Now, we were looking at 2 points on this graph. We were looking at the points -2, 2 and 1, -1. So -2, 2 is right here. Notice that's the intersection of those. And then we've got that other point that's down here. The secant line is the line that will cross that graph at both of those places. We found the average rate of change of that line from this point to this point on that quadratic. That's what a secant line does, is it crosses a graph at 2 places.